Dear students, so today we will discuss about my second paper with respect to the analytical research. So in this paper, we will have stock market forecasting by using the hybrid model of exponential fuzzy time series, right? So I will discuss in this paper that what is FTS, like fuzzy time series, and I will also talk about that how we can use in the stock exchange forecasting. So in this paper, what we did, we used exponential fuzzy time series with the EA algorithms. What is EA? EA is like evolutionary algorithm. So in the evolutionary algorithms, we have like learning automata, we have a genetic algorithm, we have a swarm optimization, we have a particle swarm optimization, we have a ant colony. So we have a lot of EA's algorithms. So the difference between the normal machine learning algorithms and evolutionary algorithm, which is we also call as a reinforcement algorithm, is that it is like it is not a rule based, it is nature based, or it is a bio based. Like so genetic algorithm is inspired from the human genetics or the biogenetics. Like swarm optimization is inspired from the birds when they are flocking together. So how they keep the velocity, how they keep the distances, and how they keep the positions when they are flocking together or they're moving together. And especially about the ant colonies, that how they make the colonies, how they follow the leaders, right? So all these are called EA, evolutionary algorithms. So we use these two to optimize our forecasting in the stock market. So, so I will be discussing you about these two, and when we apply these two together, our results were very outperforming, and the accuracy was higher. We applied our this algorithms or this our methods on 5 different stock exchange, and we took about 46 case studies in it. So the question would be that what is fuzzy logic? So basically, usually when we say usually we believe in zero and one. A computer also believe in zero and one, but there was a scientist Lutfi Zadeh. He was an American Iranian, and he proposed that there could be other possibilities as human things, like for example, if 0 is 0 and 1 is 1, so 0.1 can also be 0, 0.2 can also be 0, 0.3 can also be 0, and 0.9 can also be 1, means like yes, and 0.98 could also be yes, right? So just because human thinks differently than the machines, right? So when there is a vagueness, when there is uncertainty in the decision making, so how we make the computer thinks like a human. So the fuzzy logic comes over there, and mathematically how can we achieve this objective is through member function. So we provide some member functions in that one, and probably that is called like sets. So set theory is very much important in the fuzzy rules over here, and for creating the human reasoning, and the fuzzy logic was invented over there, and it can be used in the different fields. So what is the fuzzy logic? What is the membership function? So basically we define a set of members. If it is belongs to the specific set, then we call it zero. Or if it doesn't belongs to another set, we call it as a one, right? So if it is if for example, if our output is 0.1 or 0.2 or 0.3, then our the membership function answer would be 0. If it is belonging to 0.7 or 8 or 9, so it could be 1. So that the membership function is mapping from input values to a membership degree. So we call as a degree. So the output will be then it will be the final output. As like for example, if you see the raining, so how is the rainings doing? So raining is probabilistic. So probability is very much important in fuzzy logic, and it is ranging between 0 to 1. So we usually fuzzify, we have a fuzzy rules over there, and we fuzzify the things. So here we have like singleton fuzzifier, we have a Gaussian fuzzifier, which is like parabolic shape. We have a trapezoidal fuzzifier, which is have 4 corners. We have a triangular fuzzifier, which has a 3 corners, right? So there could be another lecture on this one. So this is the architecture of the fuzzy logic architecture, that how the fuzzy fire works, and what are the rules over there, and how the inference works, and then how we defuzzify it, because we need to defuzzify it to get either 0 or 1. So this is like, like in Boolean logic, we have like, 0, 1. Is it cold? You say yes or no. But like in fuzzy logic, we don't have two options. We have many options over here. We have like 0 0.9 very cold, and little cold is 0.25, and very less cold is 0.1. So that is the concept of the fuzzy logic. The fuzzy logic is used in, like, in a variety of things, like in control system, in, like, for example, Aramco and Babco, space and satellite, NASA, automotive system, Tesla, Neo, cars, decision making, weather forecasting, controlling the pH of the chemicals and the water, medical diagnosis, NLP, AI, expert system, chat GPT, image processing, and data aggregations, and data cleansing as well. So coming back to the paper, so we applied, like, two things. LA, which is the evolutionary algorithm. So LAA means, like, learning automata, and then we applied exponential FTS on that one. So this is like the flow chart for it. Here, this is like, particle swarm optimization. We also applied in that one. It was invented by the Candy and Eberhard in 1995, and this equation is telling about the velocity of the particle, or the bird, or you can simulate, you can with anything, and also the weights over there. And then we have x is a position. The second equation is about the x, and the r is about the random numbers, and c1 and c2 are the cognitive social scaling parameters, that how they adjust, or the birds adjust their positions. Okay, and delta t is considered to be 1 in our case. Harmonic search is also the EA, and these are the different equations we can use it. And here is the difference in the equation is the bandwidth we use it, and the random equation and the random function. Fundamental of FTS. So how, as I told you, that the membership function is very much important, and we represent the membership function in the form of the set. So sets could be like, every number is represented. For example, the set of natural number. So we can say that set of natural number is x equal to x belongs to n. So n is a natural number, right? So or we can say x belong to r. So r is a real number, right? So here could be different sets we can define according to our needs. So a polynomial fuzzy time series was like, was introduced before in the literature, and we looked to it, right? And however, the exponential fuzzy time series were like, is more better than the polynomial one. Who invented the EFTS exponentially? So Chen, he was the person who invented this one, and it was like, outperforming. So we also, like, followed the footstep of the Chen. This is the overall Chen algorithm. So the first part, the step, if you dry run this one, so the first step is the first, like, if you dry run it. So let me go back. So if we try run this one, so here we see the, okay, of of this algorithm. So first we define the universe of the scores, and then we have like we partition it, and then we fuzzify it, like, and then at the end we defuzzify it. Meanwhile, here we do some forecasting, where is like, the means, harmonic means we take over here. So this is like, the generic structure for the chain, which was invented in 1964. So we just, like, follow that one. And here is the combination of our the flow chart of the proposed method, where we combine the Horings method, the chain method, which is EFTS, and the evolutionary method for optimization. So we applied on the different stock exchange, like Taiwan Stock Exchange, Nasdaq, and S&P 500, and Dow Jones, and New York Stock Exchange. So we selected, like, some percentage, like approximately 80%, or yeah, 70 to 80% for the training set, and the rest of the for the testing. So some from January to October was selected for the training, and for testing November to December. So experimental setup is very important. So what we did, you need to have a Java 7 for it in your PC, Core i7, GPUs, like, memory should be 500 GB, and the latest window you can use it. We applied like four evolutionary algorithms, which include harmonic search, particle swarm optimization, LHS, and LAPSO. So there are certain values we need to assign, like for example, for particles, for PSO and LAPSO, we need to assign from 100 to 150. For C1 and C2 was 1.5, which is called cognitive social scaling parameters. And for HS and LHS, we assign 50 to 70. And these are like, the different parameters, is the experimental setup we need to do it. For evaluation criteria, definitely we can calculate like absolute percent error. So when these values are near to zero, the degree of accuracy is of forecasting is higher. So we need to bring this value as low as possible, near to zero. So the formula is very easy. The actual values minus the forecast value and divided by the actual values, multiply with the 100. And then we have another formula which was invented by the Fredman, and this is called root mean square error, RMSE, or sometimes we use MAPE as well, MAPE. That is also used over here. And by this way we evaluate the algorithms. So this is the end of the second paper. If you have any question, you can ask in the comment. Thank you very much.